minds. You have already done 4 chapters, so now let's start with the next chapter, which is image segmentation. Let's see what we're going to do today in image segmentation. So first, we're going to start with the formal introduction of image segmentation. We're going to classify the different image segmentation algorithms, detection of discontinuities, stages in edge detection, edge linking and boundary detection, thresholding, and region-oriented segmentation. Now let's see them one by one. Now let's see what is image segmentation. Image segmentation is a process of partitioning a digital image into multiple segments and extracting a meaningful region known as the region of interest. For example, consider this image given below. This image is like a cluster of many different people of different criteria, which is red, light blue, and dark blue. For example, if my region of interest is red, so using image segmentation algorithms and software, I can get a separate image, which is my output, as the people of only red criteria. Another example can be like your Indian flag. In Indian flag, it has 3 bands. One is of saffron, one is of white, and one is of green. If my region of interest is green, then using these algorithms and software, I can get my output will be only a band of green, whereas the rest part will be discarded. Now, your region of interest is something that particularly interests you. It's something that you want. Something that you want from an image. For example, consider sonography. What happens in sonography is that when the doctor places the device on the mother's stomach, there is an image formed in the television. Now, when you observe this image, there is one more tiny part in that image which interests you, which is the baby. That is why in this particular example, the baby is the region of interest. That is how you calculate the region of interest, something that you want. And in image segmentation, there are 2 steps. First is detection of region of interest, like we did, and second is extracting it. Now let's see the different image segmentation algorithms. Now, image segmentation algorithms are based on 2 types. One is user interaction and one is pixel relationships. Now let's see them one by one. Now in user interaction, there are 3 types. One is manual, automatic, and semi-automatic. All of these are true to their names. In manual image segmentation, everything is done manually. Everything is done by a professional. The professional sits with the computer and the software. An image is given to him, which is put as input. He will select the region of interest and extract it. This is how image segmentation is done manually. But since, due to technology advancements, this technique is hardly used. Manual image segmentation is done using control points. Now control points, you can fix control points in a particular image which will be like your boundary of the region of interest. Once this is created, once your control points are set, you can just extract it and you can get your final output. But like I said, manual is not used anymore. What is used more is automatic. Let's see what automatic is all about. In automatic, nothing is done by the professional. There is an algorithm which runs in the backend. This algorithm will input the image, it will detect the ROI, and it will extract it. Everything is done automatically. Nothing is done by the professional. But in some cases, what happens is that once the automatic segmentation is done, there is manual segmentation performed after that. But that is only and only for the purpose of verification and validating the output. Automatic segmentation is used in most companies and in most places because it's faster and requires literally no manpower. Let's see what is semi-automatic. In semi-automatic, it's like a blend of manual and automatic segmentation. In image segmentation, there are 2 steps. First is detection of ROI and second is extracting it. So this detection of ROI is done by the professional and extracting is done by the algorithm. This semi-automatic method is also called as assisted manual segmentation, since it's done manually but it's assisted by the software. Semi-automatic method is like a blend of both. Semi-automatic method is simpler than manual, but not as simple as automatic. Now let's see the next type. Next type is based on pixel relationships. In this type, the image is segmented based on particular pixels between the relationships in the pixel. So now one is contextual and second is non-contextual. In contextual, the images are segmented based on their similarities. For example, if there is an image, black and white image, so the final output will be two images, one having black pixels and the second having only white pixels. This is how contextual image segmentation is done. In non-contextual, the similarity part is ignored. The image segmentation is done based on some threshold. Like this can be like a foreground background segmentation. For example, consider a image of a horse grazing on some green grass. So now you can select your foreground and your background, and this is how image segmentation can be done. You can get your horse separately and your grass separately. Typically, in this non-contextual image segmentation, it is done on the basis of grayscale. Grayscale is a value of each pixel that carries the light intensity information. Non-contextual image segmentation is majorly done using this grayscale value. Now let's move on and let's see the ahead concepts. Now, detection of discontinuities. Like I just said, image segmentation can be done based on the grayscale. So now, if the value of the grayscale is pretty similar, then that is similarity. Whereas if there is any abrupt change in between, that is your discontinuity. So now there are three basic types of gray level discontinuities in a digital image. They are point, lines, and edges. Let's see them one by one. Point detection. So the main idea of this is to detect a point in the entire image whose gray level is significantly different from its background in the homogeneous area. So now your R over here, which is calculated by this formula, is your region. Now there will be a specific threshold. So now the point that you want to compare will be in your center. For example, now here it will be Z5. Now using ZK and WK will be your weight, is that the intensity, will be the weight of that particular point, and ZK will be your intensity. So using this formula, we calculate R. If R exceeds the threshold which is predefined, that means the point at the center, which is Z5, is the gray level of that point significantly different. This is how point detection is done. Now let's move on to line detection. Line detection is like the next level of complexity in the direction of image discontinuity. Now Ri will be the response of the entire part, and R1 will be a horizontal, R2 will be a vertical, R3 will be of plus 45 degree, and R4 will be of minus 45 degree. Using the same using point in each of these parts, point detection is done. So now you can see that there is, in the horizontal part, there is 2, 2 and 2 in one horizontal line, which means there is a abrupt change in the gray level in one straight line. So using this formula, you can calculate Ri, which is the region, and once this region if the value of this region exceeds the threshold in one straight line, which means there is a line detected in which the gray level has changed abruptly. Now let's move on to edge detection. Now as you can see in this image, what edge detection does, that it just discovers the edge in each image, in each part of the image. It provides like an outline to the object. It is used for finding the boundaries within images. Like we did earlier, it works by detecting discontinuities in brightness. Now your grayscale is like your value of the brightness of the light intensity. So using that, you can find out the edge of each image, and that can be used for image segmentation and extraction. Now these are the different types of edges, which is step, ramp, line and roof. Based on these types, you can differentiate the different types of edges. Now the remaining part will be done in the next video. Thank you.